Welcome to Ask and Learn.
So this is a similar problem which we have done before, and again a skier problem. So we have a skier which is traveling at 9 meters per second at this location, reaches the foot steady upward 19 degrees incline and glides 12 meters up this slope before coming to rest, which means he's starting off at this position here and then coming to rest at this position out here. And the angle is theta. So we have seen in this case that the normal force is equals to mg cos theta. So the force of friction is equals to mu k mg cos theta. And the skier is traveling a distance of d up the incline and coming to rest at that location. So we have the two locations out here. We have location 1 and location 2. At location 1, we have y1 is equals to 0. There's no height. And v1 equals 9 meters per second at this location. And at location 2, y2 is basically equals to d sine theta. So you see, if you complete the right angle triangle, this is the height. We are interested in this height of y2 at this location. So if you solve by trigonometry, you will get y2 is h by d is sine theta. So therefore h is d sine theta. And the velocity at that location is 0 because he's coming to rest. So applying the conservation of energy at location 1 and location 2. So E1 is equals to E2. So we have half mv1 squared plus mgy1 is the total energy at location 1 is equals to half mv2 squared plus mgy2. Now again, the energy at location 1 and the energy at location 2 would have been the same if there were no friction. But since there is friction, the energy at location 1 is equals to the energy at location 2 plus some work done by friction, which is F times D. So we can see that it's half mv1 squared plus 0, because the potential energy at location 1 is 0, is equals to the kinetic energy at top, which is 0 plus mg d sine theta plus f of f we have seen is equals to mu k mg cos theta times d. All right, so if you solve that equation, you'll be getting mu k is equals to half m vi squared minus mgd sine theta divided by mgd cos theta. Now m cancels out, so we are just left with half v1 squared minus gd sine theta divided by gd cos theta. And in fact, if you solve it further, this sine theta by cos theta converts to tan theta. So therefore, our equation is further simplified to v1 squared by 2 gd cos theta, which means dividing these two, minus, and now you can see that gd sine theta and gd cos theta, gd and gd cancels. This one and this one cancels, and you're left with simply tan theta. So I'll just plug in the values on this page here. So we get is equals to 9 squared divided by 2 times 9.8 times 12 cos 19 minus tan 19. If you solve that, the value of mu k is 0.020, and that is our answer for the coefficient